All right, folks, so let's go ahead and go through 15, 16, and 17 and see how you did. First, we identify this as a logarithmic equation. The two logs are the same, so we can cross them off, and that gives us x plus 20 equals 6x. So subtract the x, that gives me 20 equals 5x, and thus x equals 4. But before we put a box around it, we need to check it in both answer parts of the log. So is 4 plus 20 greater than 0? Sure is. And is 6 times 4 greater than 0? It is as well. So x equals 4 truly is our solution. Now looking at number 16, we see that it is a logarithmic equation, and since there is only one log here, we are going to write it in exponential form. So again, folks, don't just think, oh, I'm just going to cross off that log and say negative 6x equals 1, because since there isn't a log on the other side, there is nothing for us to cross off. So anytime you just have a single log, you must write it in exponential form. So big animal ears. So 8 to the first equals negative 6x. Now at this point, I've written it in exponential form, but this is a ground level equation because my variable is on the ground and not up in the exponent. So how are we going to solve this equation for x? We're going to divide both sides by negative 6. And always, reducing those fractions. 8 over negative 6 gives me negative 4/3. But before we put a box around it, we have to check this in the answer part of the log. So looking here, if I have negative 6 times a negative 4/3, that would be positive 24 over 3 or positive 8. So is positive 8 greater than 0? It sure is. So x equals negative 4/3 is really my solution. So again, just to emphasize, it's not that the solution needs to be greater than 0. It's all about what it does in the answer part of the log. So let's go ahead and look at number 17. It's a logarithmic equation. We've got two logs, one on either side, that are the same. So we can cross those off. X minus 1 equals 2x. So let's see, negative 1, subtract that x over, that gives me x. So x is equal to negative 1. But before I put a box around it, we have to check for extraneous solutions. So is negative 1 minus 1 greater than 0? Oh, nope, negative 2 is not greater than 0. So that solution didn't work. So the actual answer to this problem is there isn't one. No solution. All right, folks, so with that in mind, I am going to have you guys work on number 18 and number 19. I will not be going over those in this video, but we're going to be looking at number 20 together. So on number 20, same as the last problem, where we have two logs, so we can cross them off because they're the same on both sides. So then x squared minus 4 equals 3x. Now, what type of equation are we now looking at? It is ground level, looking at the position of our variables. So sometimes students will say that this one is exponential. Yes, it does have an exponent, that too, but my variable position is on the ground. So this is a ground level equation, and specifically, it is a quadratic. Folks, how do we solve a quadratic equation? The easiest way is to factor it. And folks, I'm pretty sure I mentioned in the notes, I am not going to give you any problems on homework, on tests that require using the quadratic formula. So if you can't factor the expression, it means you done goofed somewhere. So be aware of that as you start working through the assignment over this. So before we factor, we do need it to be equal to 0 first, just as I mentioned in the notes over this. So to keep our a value positive, I would subtract the 3x over. And then product of negative 4, sum of negative 3, that would be x minus 4, and x plus 1 equals 0. So using that 0 product property, if I have something times something equals 0, either this factor equals 0 or this factor equals 0. So x would be equal to 4, and x is equal to negative 1. But before we put a box around it, we have to check both of these solutions in the answer part of our log. So if we plug in 4, 4 squared is 16. 16 minus 4 is 12. 12 is greater than 0, so it works in my first log. We check it in the second one. 3 times 4 is 12. 12 is greater than 0. Well, bam! That truly is a solution. -1 squared is 1. Minus 4 is -3. Wah, wah. That one would be extraneous. So, folks, again, if you're like, well, are we always just going to have one solution from this? No, there's actually problems where you end up with both solutions working. So it's not about, oh, I got a quadratic, so I can only have one. It's all about what those solutions do in the answer part of the log. So turning the page, we're going to be looking at a few more of these together. So on number 21, we identify this as a logarithmic equation, but this one is different because there are 3 logs instead of just 1 or 2. Now, when we have more than 2 logs, or sometimes 2 or more logs, we are always going to start by condensing the 2 that are on the same side together. Sorry, that 21 is not actually part of the problem. So we're going to start by condensing those 2 logs using our condensing rules. So these 2 logs are separated by addition. So what operation will we use to condense them? We'll condense by multiplying the answer parts. So I'm going to condense by multiplying. So this is now log base 4 of 5x equals log base 4 of 60. And now this is similar to the problems we were just doing, where I have a 2-log equation, same log on both sides, so we can cross those off with each other. So 5x equals 60 and x equals 12. But before we put a box around it, checking in all 3 answer parts of our original log expression, 5 is greater than 0, x is greater than 0, because x would be 12, so 12 is greater than 0. 60 is greater than 0, so boom, that really is our solution. So looking at number 22, here we also have 3 logs. So we're going to take the 2 that are on the same side, and condense them. They are separated by addition, so we are going to condense again by multiplying. So log base 6 of 2c, and the 8 gives me 16c, equals 80. Equals log base 6 of 80. And folks, I really want you to explicitly show every single step here, and you'll see why once we get to some of the more complicated problems, because if I had just written 80 here and it dropped off the logs right away, there are some problems where it's very dangerous if you try to go too fast. So we'll get into that on some of the next few problems. So we have the same 2 logs, we can cross them off. So 16c equals 80. So c equals 5. Plugging into all 3 answer parts of all 3 logs. 2 times 5 is 10. 10 is greater than 0. 8 is greater than 0. 80 is greater than 0. So c equals 5 really is our solution. Moving on to number 23. These 2 logs are separated by subtraction. So we are going to need to condense them by division. So again, folks, you don't have to do anything fancy and like move this log over to the other side. Just when you have 2 or more logs, always condense the 2 that are on the same side first. So these 2 are separated by subtraction. So we're going to condense by dividing. So q over 3 equals log base 2 of 7. So now I have a 2-log expression, and I can cross off those same 2 logs from both sides. So q over 3 equals 7. How do we solve for q? Times both sides by 3. Q equals 21. Checking in all 3 answer parts of the log. 21, when we plug it in, is greater than 0. 3 is greater than 0. 7 is greater than 0. So 21 really is our solution. All right, folks. So on your own, I would like you to do number 24 and number 25. And we're going to go ahead and go through number 26 together, and I want you to put a big star by this one. 26 is kind of the bane of the existence of Algebra 2 students. This is consistently one of the most frequently missed problems on our test over logs. So I want you to look very closely, because I am going to begin this problem by making a critical error. So when I look at this equation, we see that we have 2 logs that are on the same side. So similar to what we did on the last problem, I am going to condense them. So they're separated by addition. So I'm going to condense by multiplying. So the critical error would be saying 3D equals 3 and D equals 1. Folks, D does not equal 1. And here's why. When I condense these two logs together, I'm taking 2 logs and condensing it down to 1 log. So you need to be sure when you condense that you don't try to skip a step and stop writing the log. Because on number 23, I had a log on both sides, so those logs canceled with each other. But here, when I condense those 2 logs, this is now only a single log equation. And how do we solve a single log equation? We put it in exponential form. So big, animal, ears. So my base is 3, my exponent is 3, and my answer is 3D. So 27 equals 3D. Also be careful, folks. It's not 3 times 3. It's 3 times 3 times 3 is 27. So D would be equal to 9. But again, before we put a box around it, check it in the answer part of the log. So 9 is greater than 0. 3 is greater than 0. Now, is this 3 over here, is that an answer part of a log? No. That 3 doesn't affect my checking at all. That is just a floating chunk of 3. So D equals 9 is my solution. So folks, I would put more stars by this problem. Just make sure that you are showing your work and that when you condense, you still have the log in front of your answer part of the log. So don't try to skip too many steps. I know it can get annoying to write that log base whatever every single time, but you are going to want to make sure you do that so that you don't fall into this trap. So we are going to look at number 28 and 29. So you'll have to do number 27 on your own, but we'll look at number 28 and 29 together. So on 28, we have 1, 2, 3 separate logs. So we're going to take the 2 that are on the same side and condense them. They are separated by addition. So we're going to condense by multiplying. So if I multiply the answer parts of those logs together, we're actually going to be distributing that x to both. So 2x squared minus 3x. And what critical error have I just made? We have to write the log in front. So when you condense 2 logs to be 1 log, it is still a log expression. So make sure you include that log base 4. Then we've got equals log base 4 of 2. So now we cross these off. Pew, pew. And we have 2x squared minus 3x equals 2. So now, how do I solve from here? Well, this is a ground level quadratic expression. So we need to set it equal to 0 before we factor. So 2x squared minus 3x minus 2 equals 0. And there's no GCF, so folks, we are going to have to use the X method here. So I recommend that you pause the video, see if you can either do the X method or whatever type of factoring that you use to solve when there's a coefficient in front of your squared term. But I would pause the video and try this on your own first. So to get a product of 2, 1x and 2x. To get a product of 2, I'm going to do 2 and 1. So 1x times 1 is 1x. 2x times 2, multiplying on the x is 4x. So is there a way for me to get a sum of negative 3x from these? The 4 would need to be negative, and thus the 2 would need to be negative. So to write these as factors, the 1 gets paired with the negative 2. 2 gets paired with the 1. So remember, these represent the parts of foiling, so we multiply those. That's our O, that's our I, that's our L. So the terms that get paired in parentheses are the ones that we don't actually multiply. So x minus 2, 2x plus 1 equals 0. So x is equal to 2, or x is equal to negative 1/2. Now, checking these both in all 3 answer parts of the log in the original problem, is 2 greater than 0? Sure is. is 2 times 2 is 4. 4 minus 3 is 1. Is 1 greater than 0? It sure is. And 2 is greater than 0. So, bam, x equals 2 is a solution. I plug in -1/2. Is -1/2 greater than 0? Ooh, that's going to be a no. So it doesn't matter what it's doing in the other answer parts of the other logs. If it doesn't work in one, it doesn't work at all. All right, folks, number 29. This one, I want you to pause the video and try it on your own. And I am going to tell you straight up that the answer for this one is not 0 and that it is also not 25. So hopefully you had a chance to try working through that one. When we start this problem, we see that we have 2 logs on the same side, which we would try to condense. The problem here, well, our first of many problems with this problem we're working on, is that we cannot currently condense these because of that 2 that's in front of the second log. So you may remember that one of our rules with condensing was sending coefficients to the clouds. We can't condense when there's a coefficient in front. So I have to send that 2 back up to the clouds as an exponent of 5 first. So log base 2 of r plus log base 2 of 5 squared equals 0. So now I can condense these. They're separated by addition, so we condense by multiplying. So 5 squared is 25. So 25r equals 0. And that right there, folks, is the critical error once again. Because it's not just 25r. When I condense these 2 logs, I still have log base 2 there. So I can't cross off this log base 2 because there's not another log base 2 on the other side. And sometimes I see really goofy things on the test where students will just like slide in a log base 2 here out of nowhere. So they'll just put in a single log, which is not mathematically legal at all. So if you do something to one side, you'd have to do it to the other side. So the only way of solving this now single log expression is to put it in exponential form. That's my big, that's my animal, that's my ears. So 2 to the 0 equals 25r, and anything to the 0 power is 1. So 1 equals 25r, divide by 25. Oh, so r is 1/25. Checking in the answer parts of the logs, is 1/25 greater than 0? Yup. Is 5 greater than 0? Also yup. The 0 is not an answer part of a log, so it doesn't matter. So that is my solution. So folks, more stars around number 29. Because what's tough about these is remembering that after you condense to put in that log. Because if there's not a log on the other side of the equation, you're not going to be able to cancel this. So, folks, I would like you to finish off this page on your own, paying special attention to number 34. 34's going to be one where you'll be tempted to make that same critical error. And on number 35, my hint I'm going to give you is GCF. So once you condense and get to the factoring portion of that, to factor it, you can always take out you can take out a GCF on this one. So again, folks, you're going to be doing any problems that we either didn't show work on. So like number 3 and number 4, you'll need to show work on those. Number 18 and 19, you will need to complete. And all of the rest on page 13 as well. And I will be looking for work on all of these problems that we did together as well. And that's where we will end the video for today.